Okay, this is really pretty much the last completely new thing we have to do this year. Box and whisker plots, or sometimes they're just called box plots. All right, it can be called both ways. I'll show you why in a second, but last completely new thing we've got to do. Like a lot of things I've told you this year, once you get it, it's not something that's crazy difficult to do in terms of the math. I'm even going to eventually show you next week how to do it on the calculators. Obviously, that's going to make it a little bit easier. The problem with box plots or box and whisker plots are it takes some time to do the problems. So you got to take the time to actually follow the steps. So this is a box plot. Okay? What it has and why it's called a box and whisker plot. You see how we got two boxes in the middle. We got some whiskers off to the side, right? You know, you got like, and there's your cat face, right? See, box and whisker plot. So what we have is we have a whisker, a box, and a whisker. So how many sections is that? 4. Those sections, each section is referred to as a quartile. Think like quarter, right? 4 quarters in a dollar, 4 quarters in a game, 4 quarts in a gallon, right? Quart, gonna mean 4. So each one is a quartile. And we'll get to those a little bit more in a second. What a box plot does is it displays our data or uses our data using 5 key numbers. So there's 5 things we got to kind of figure out. Now there's more things they can ask about. There actually ends up being about 7 different things they could ask. Maybe even more than that, but you know, there's 5 primary things. The difference between the first and third quartile is called the interquartile range. Interquartile range. Inter means it's on the inside. Quartile are the 4 sections. So interquartile are the 2 sections on the inside. That's your box, okay? So interquartile range is the range on the box. So from one edge of the rectangle to the other edge. All right, the smallest piece of data. What's the smallest number called? I need an M word for it. Nope. The smallest piece of data is the minimum. That is the first of the 5 numbers you would get. Because your first step to doing this is putting them in order from least to greatest. Okay? I'm going to go ahead and letter these because this will make this easier to label. So we got A, B, C, D, E. Down here on this box plot, we'll put a dot there too. That's our minimum. So if you label it with some letters like that, that might help you kind of keep it straight a little bit. So there's our minimum. When we have a data set, we put it in order from least to greatest. Minimum's going to be the first one listed. What's the M word for the largest piece then?
Maximum.
Maximum. So obviously I skipped the middle 3, but you know the maximum and the minimum are going to be the easiest ones to figure out. So our maximum is there at the far right. So step 1, put them in order from least to greatest. Once you have them in order from least to greatest, you know, minimum's going to be your first number listed, maximum's your last number listed. The next number that you find or that you can figure out is the C one on here, the median. I'm not really sure why it says the median there and then the answer blank that they wanted was median, but hey, whatever. That's what they decided to do. The median is also sometimes, very rarely, but sometimes called the second quartile, okay? What that's going to be is that line right there, okay? So the line that cuts the box is the median. You'll notice on my graph here is that C right there in the middle of my box plot? No. What it is it's in the middle of my data though. That's what it's the median of. If I listed all the data, it'd be in the middle of it. When you draw it as a box plot, it doesn't always put it right in the middle though. And I'll show you why in a little bit. Then what we have, our B value is the first quartile. That's going to be right there. And our D is the third quartile. So if we go back to interquartile range, it's the difference between the first quartile and the third quartile. So when we have to find interquartile range, we do Q3 minus Q1. That first quartile is also sometimes called the lower median, and the third quartile is sometimes called the upper median. And again, you'll see why in a bit when we do one. Any questions on any of that? All right, so this one's not on your paper, but here's what we've got. I've got some data listed from least to greatest, okay? In this case, I've got 11 pieces of data. So if I'm trying to find the median, that means my median is going to be right here. That's 23. We can see either side of the 23, we got 5 numbers, right? It cut it in half. My median is the middle here. That's 23. So median's 23. Like I said, that's also sometimes called the second quartile. All right, what was my minimum? 1. So our minimum here is 1. My maximum, 90. Now we didn't just go over this one, but I got range listed there because range is something that can sometimes be asked. Who can tell me the range for my data? David? 89. Minimum, or range is maximum minus minimum. So that's 89. Now to find the first quartile is the median of the lower half of our data, okay? So the lower half of our data are those numbers right there. We don't count the median. If the median was between 2 numbers, we would count the number that's on that side of the line. So I've got 5 listed. That puts my median of the lower half right there, 14. So that's my first quartile. We do the same thing for the upper half. We find the median of the upper half. So when I've got those 5 there, my middle number is at 78, like we have right here. Y'all, you realize how like I drew this up here? Oh my goodness, look at that. That's how it kind of fits, okay? So my box plot up here, everything was spaced out evenly. All those sections look exactly the same, don't they? The reason they don't when you graph it, if we're going here, 1 to 14 is only a distance of 13, right? But 23 to 78, that's a distance of 55. That's why that space looks longer on the actual box plot. That makes sense? So what's my interquartile range? Who can tell me that? Jacob? 64 is correct. Interquartile range is Q3 minus Q1. So it's the upper median minus the lower median. All right, so in this case, 78 minus 14. Any questions on that? All right, so again, you can see these two box plots look differently, right? This one looks nice and balanced, the one on the top. This one on the bottom doesn't look quite as balanced. For this one on the top, each one of these sections is 25% of the data. So 25% of my data is there, 25%'s there, 25%'s there, 25%'s there. For this box plot down here, for these sections, are these the same? Yeah, they are. Each section is 25% of the data. So each whisker, each half of the rectangle, or each box there, is 25% of your data. The reason it's sometimes more stretched out or more squished together looking is based on how far out the data is spread. If the numbers are close together, it makes it shorter. If they're farther apart, it kind of stretches it out like the green whisker here on the bottom. Y'all follow on that? There's going to be questions where they ask you, like, what percentage is less than this number or greater than this number? And all you do is you find that number on the number line and you just count how many sections. And each section's 25%. So basically your answers are like 0, 25, 50, 75, or 100, right? Just to go over again, range, distance from the lowest value to the highest value. Interquartile range isn't exactly the same. It's from Q1 to Q3, distance on the boxes. So that's a little bit different looking, but they both have the word range because they're talking about the distance on or in between some numbers. All right, so if I have that data set at the top, what do I need to do first? I need to put them in order from least to greatest. Now, I mean, to do that, you do have to find the minimum, yes. But we're going to put them in order from least to greatest. Okay? So we go ahead. We got them in order from least to greatest. Now, step 2. I'm going to cut my data in half. I'm going to find the median. So we got, you can always do like we did before. We can cross them out, right, if needed. And when you cross them out, if you get two numbers, which is what we have, your median is in between those two numbers. What is my median, though? What number? 30. Like when it's the same number, it's still that number, but the line we would draw would be in between those two numbers, okay? So now that we got our median, our third step, and it really doesn't exactly matter which order we do the third and fourth step, but we're going to find the median for each half. I guess I put them just as one step. So we find the median for the lower half, we find the median for the upper half. When I'm looking for the lower half or the upper half, I'm including all of those numbers. That 30 isn't part of the median because that's not where the line was drawn, okay? I have an even amount of data. So that means my median for this lower half is going to be there. My median for the upper half is going to be right there. How many numbers are in each section? 3. Every section on your box and whisker plot, every quartile should have the same amount of data. So we divided it up. It's chopped up nice and even. So our fourth step here, going to be to make that box and whisker plot. All right, so what's my minimum? 14. What's my maximum? So if I wanted to draw this, I'm not even going to bother drawing this like super accurately, okay? I'm not going to worry about where each one is, because you can just see what the numbers are, and that's going to answer any questions you really would have to answer on it. So what's my median? 30. What's my lower median? 23. It's between 20 and 26, so that makes it 23. Upper median? 34. Yeah, between 33 and 35 is 34. And my whiskers went a little droopy, but we get the idea, right? Does that look super nice and neat? No. But every question that I might have to answer can be answered using this box and whisker plot, or even just what I draw up here on top of the data. All right, so y'all got some animal crackers on your sheet. All right, what are we going to do first? We're going to do this one step at a time, okay? So what are we doing first? Put them in order from least to greatest. Everybody put them in order from least to greatest. Ford, give them to me, least to greatest.
34, 45, 47, 48, 48, 49, 50.
All right, everybody good with that part? Any questions on that? All right, now, find the median. Everybody go ahead and find that median. Sydney?
48.
Median right there. I got 3 on either side. Median, 48. I guess I skipped. What's the minimum? Who can tell me? Mason? 34 is the minimum. Maximum? Jeremiah? 50 maximum. Okay? Now we need Q1 and Q3. So go ahead and find Q1 first. Gray? 45 is correct. Q1 is the median of the lower half, so that makes it 45. Q3, Robert? 49 is correct. That's the median of the upper half. So when I go to graph this one we got a number line where it's numbered. My minimum, you don't always see a dot. I like putting a dot. So the minimum would be at 34. My maximum would be over here at 50. My median is at 48. My lower median, or my first quartile, is at 45. My upper median, 49. So you see we got a pretty long whisker there, don't we? That's because that 34 is really skewing the data. It's making it go way off to the left. Someone got a whole lot less animal crackers in their box than most of the others. Any questions on that? No? All right, y'all go ahead, try number 2 here. Go ahead and get all 5 numbers and put them in order from least to greatest and all that first. I'm not as concerned about y'all being able to draw the picture. Are you going to have to draw a box and whisker plot for your EOG? No. But you do have to be able to get these 5 numbers and recognize them on a box and whisker plot. Minimum, Sarah E. 7's correct. Maximum, Sydney. Whoops. 19's correct. Median, let's go with median. Ford. 11's correct. To find the median, if you divide the number of data points you have by 2, it will tell you how many should be on each half. So there's 13 pieces of data. 13 divided by 2 is 6.5. That means if you go 1, 2, 3, 4, 5, 6, the next one's your median. And then you have 6 more on the other side, okay? Quartile 1, first quartile, Kyle. 9 is correct. And then Q3, David. 15's correct. All right, so like I said, that's basically how it would look. I'm not going to worry about doing it on the number line. If you want to do that on your paper, you can. But any questions on that? Do you see what I'm saying? Like, is this crazy difficult math to do? No, it takes a minute though, doesn't it? Like, today's video will be one of the longest ones. All right, so flip it over. Not worried about the very bottom there. All right, so here's how these questions will look. We've got a box and whisker plot there with the number of college applications some of these high school seniors applied to or filled out. So let's see what we can answer on these. Number 1 there says, what is the range of the number of colleges? So who thinks they can give me the range? Greg? Nope. Robert? Nope. 9. All right, range is maximum minus minimum. Our maximum right here, it's going to be between 8 and 10. What's between 8 and 10? 9. And this is talking about college applications. You can't apply to like half of a college, so they got to be the whole numbers. And then down here, we got 0. So 9 minus 0 gives us a range of 9. All right, now we need the median. Who can tell me the median? Sarah E. 6 is correct. Median is that middle line on our box. So we got our median, median 6. Number 6 here, the interquartile range. Who can give me interquartile range? Kyle? 4 is correct. Interquartile range is Q3 minus Q1. Now it gets a little bit different. Number 7 here is asking which quartile represents the greatest spread in the data. So how many quartiles are there? 4. There's 4 quartiles, 4 sections. So basically what it's asking you, there's your first quartile, there's your second quartile, third quartile, fourth quartile, the 4 sections. It's asking you which quartile represents the greatest spread in the data. Robert? First quartile. So basically, you're looking at the range on each section. So the whisker, box, box, whisker. Those are the 4 quartiles. Whisker, box, box, whisker. So whichever one's the most spread out has the greatest spread. Whichever one's the least spread out and more scrunched together has the least amount. So you know, that 4th quartile where it's going from just 8 to 9, that one's a little more squished together. Let's just go with the first part there. Who can tell me why quartile 1 is larger than quartile 4? Sydney? No, it doesn't have more data. Each quartile actually has the same amount of data. Each one's 25% of the data. Kyle? Yeah, it's literally asking you why, though. It's saying why is it longer. Try. What does? Take that. The data's more spread out. All right. So, Sydney, you were on the right track with that. But it's just the data's going to be more spread out. It's not that it has more or less data. It's the spread on the data. So if you look quartile 2 and quartile 3, the box sections, they're the same size. They're going to have the same spread to them.